I will demonstrate with our in-orbit asset now, because my presentation is focalized on present how is can be useful our in-orbit infrastructure in order to monitor the greenhouse gases, and then only 2 words on my division and what are the main objectives. Of course, we are part of a European Space Agency. We are member states and represent Italy in the EU, in Copernicus. We are members also and delegates in EUMETSAT, and we are partner of in the widest international framework with the NASA, CNES, and others, and all the major space agencies. But only to focalize on what we do for the infrastructure and what is useful for the greenhouse gases monitor. Let me say something about the 8 major objectives in the Earth observation frame of Italian Space Agency. We have some objectives. The first one, of course, is what related to the sustain the future of synthetic aperture radar for the constellation of Cosmos Skymed, of course, but not only, also with experiment not only in X-band, but also in L-band, and for considering also the SAOCOM Italian contribution in the Argentina mission, and also with the small satellites. But the point that we focalize today is on hyperspectral mission that we have still in orbit with PRISMA, and also with the roadmap for the future, the second generation, with a new special resolution. The other objective is on thermal infrared, and we plan to have the national contribution with a small satellite, and also the partnership with NASA on SPG thermal infrared with JPL. Another one is to achieve autonomy not only in synthetic aperture radar, but also in high resolution optical system. A point very interesting to understand the characteristic of the atmosphere is on a LiDAR capability that we have at national level with some competencies, very strong competencies in a Leonardo company. And new instrument, a lot of instrument like radiometers on quantum technology, that we have a large spectrum of assets that we have in orbit, develop and plan. And not at the end, but very important, it's another of our objective is to strengthen Earth science and application, supporting the national communities for science and applications, and also to pull users towards our data in order to produce a very interesting application like that I'll present now. Okay, this is our Earth observation fleet of a national level. It is a very populated for operational, like Cosmos Skymed, like the contribution SAOCOM, like the hyperspectral in development, and also in planet. But now we are focusing on the hyperspectral development, in particular on the PRISMA mission already in orbit, and hyperspectral mission with is 240 bands between in the visible, in near infrared, and shortwave infrared, that can be counted amongst the brightest success of my agency and beyond, because we are planning the next generation of PRISMA, and that can guarantee the continuity of the observations and also enhancing the performances, moving from 30 meters of resolution to 10 meters of resolution on demand. Okay, but move directly to the focus of my speech. Of course, is on greenhouse gases, and this is one due to anthropogenic greenhouse gas emission. Our climate is changing, and we need to prepare, mitigate, and adapt to this problem. And the forecast that we need require accurate information about the sources of natural and anthropogenic greenhouse gases, in particular carbon dioxide and methane. Presently, greenhouse gases, this is a picture of Taranto, and you can see the dramatic situation that it's an urban power steel plant that we have to consider as for the effect of this type of industrialization in southern Italy. And regarding the methane mapping from space, the industrial methane emission play for sure a major role in the methane budget. And is very important, our instrument on board of Prisma, hyperspectral, because emitters are typically point sources from space. Strong emission as plumes from small surface elements. Then our hyperspectral satellite, like considering the 30 meters ground space distance, is very interesting as the data extracted from this system to understand what are the emitters that produce more methane in the world. And also, typically, a small number of emitters account for a large fraction of total emission. The capability of the spectrometry from space, like Prisma, for methane mapping, has been demonstrating using Aviris from plane, not from space. Then the Prisma is one of first hyperspectral instrument that then could provide the real proof that from space we can understand the plume from these industrial emissions are in terms of methane source. CO2 mapping from space. The emission from power plants, of course, represent the largest sources of anthropogenic greenhouse gases. We have also, in this case, strong point sources. And in CO2, the estimation often lack, as I said before, I don't remember the name of a previous speaker, lack atmospheric measurements from space, from top down, and instead rely on bottom-up estimation on fuel consumption, population dynamics, and other data. The objective of this presentation is to demonstrate that remote sensing with imaging spectrometer offers a new capability to do top-down monitoring, and hyperspectral mission like Prisma could help in the quantification and measurement of the emissions. What is Prisma? Prisma is a full Italian mission, and with basically two instruments. One hyperspectral sensor from 0.4 to 2.5 micron, then in visible, near infrared, and shortwave infrared, and a panchromatic camera that is co-registered, that produces simultaneous acquisition of images in all the channels. As I said before, this mission was launched in 2019 and now is full operational. How it works? It works looking at the reflected radiance from energy from the sun, and is able to acquire multiple images, the 240 bands that can collect images from each of this spectrum. This is very important. The production of this instrument is a data cube with a populated data. How can we acquire data from Prisma regarding to map methane and CO2? We consider the absorption feature between 2 and 2.5 micron caused by atmospheric absorption of methane and CO2. Then this is a simulated spectrum of Prisma, and I indicated the 2 points where theoretically the absorption lines could be useful to extract the content in the plumes from industrial site of methane and CO2. And this is very interesting results. These are produced with the JPL that use with our Prisma data. Is for in this case we have the plumes detected and quantified of methane in oil and gas wells in Permian Basin. I said before in previous presentation in Algeria, in Turkmenistan, in Shaanxi in China. And then with our instrument, it's possible to give some information about the content of this plume. We will see that we have some constraints that are linked to the reflectivity of the surface in some cases. We have similar plumes, content of CO2, also in plumes detected at 3 coal-fired power plants in US, Poland, and South Korea. Then these are very important results. We reported also the reference of these interesting works. Another point that we can show now is also the simultaneously retrieving column average of CO2 and methane concentration with the resolution of Prisma over 30 meters. And of course, this capability has not been available, demonstrated with any single satellite previous Prisma. What's new beyond Prisma? Beyond Prisma, we have the second generation that we plan to launch in 2025. Also, this mission is entirely funded by the Italian Space Agency. And of course, the objective is to guarantee the continuity of the acquisition, but with strong enhancement in performance. Of course, we have some SWOT that in Prisma is limited to 30 kilometers, and SNR that is very good and is comparable to the CHIME Sentinel mission, using the platform agility, then the attitude control of the platform. And we introduce in the second generation 2 acquisition mode, the strip map and the spotlight. The very interesting is the strip map image is like Prisma present generation. And the spotlight image is has a functionality very important that is and panchromatic that in the previous case 5 meters is reduced to 2.5 meters. And is able to acquire more than 2 million kilometers daily. Then it is using, of course, off-nadir movement of the platform of plus minus 30 degrees respect to the nadir acquisition. And we have also in this case a very low revisit time, 72 hours. With this constraint in off-nadir angle. Concluding, we showed that Prisma has the capability of detecting and quantifying greenhouse gases such as methane and CO2 at high spatial resolution. We wait for MethaneSat in order to work jointly to this goal. Joint CO2 and methane remote sensing capability permit the fuller greenhouse gases accounting at co-emitting facilities. We can monitor current and coming with current and coming spectral emission, not only at the national level, but also with the German NMAP that is planned to launch next year. Methods for the detection and quantification of methane point emission with Prisma can play an important role in this field. And we wait for the second generation in 2025 in order to increase this capability to 10 meters of spatial resolution. Thank you for your attention, and please register on our website to download our data. There is open and free data without commercial permission for the moment, and you see on the screen our web link. Thank you very much.